Hi, hello, I'm Kiran Kumar from Nature of Physics. Today topic is reflection and transmission of the waves from the waves chapter. See, this is the boundary of two media, medium 1 and medium 2. And this is the incident ray displacement equation yi, which is equal to a sine omega t minus k1x, and this is the reflected wave. So yr, which is equal to ar sine omega t minus of minus plus k1x. Next, this is the transmitted wave. So transmitted wave, that is yt, which is equal to at sine omega t minus k2x. Here opposite direction, that's why taken here plus sign. And k1 is propagation constant in the first medium, k2 is the propagation constant in the second medium. Okay, here yi is the displacement of the wave, that is incident wave, yr is the reflected wave, and yt is the transmitted wave. And now here ar, which is equal to small ar into capital A, and capital AT, which is equal to small at into A. Here ar is the amplitude of the reflected wave, and capital A is the amplitude of the incident wave, and at is the amplitude of the transmitted wave, and capital A is the amplitude of the instant wave. Here ar and at represent the coefficient of reflected and transmitted for the two media of the boundary particle. ar and at represent the coefficient of reflection and transmission for the boundary of two media. Okay, and we can write here ar, which is equal to capital ar by a, and at, which is equal to capital at by capital A. Okay, so then continuation here, boundary of medium particle. For this, x is equal to 0. Before going to that, here the displacement of the medium particle in the two medium must be added. See, for this yi plus yr, which is equal to yt, must be equated. Sorry for the mistake here, must be equated. See, so here first medium, two waves, that is displacement is yi plus yr is equal to, that is transmitted. This is the first medium, this is the second medium. Okay, so then here the values are replacing. Before going to that, one more step, that is for boundary particle x is equal to 0, and now the values are, that is a sine omega t plus ar sine omega t, which is equal to at sine omega t, because of x is equal to 0. Then the values in which sine omega t is common and cancel, we got here a, which is equal to a plus ar, which is equal to at. So this is taken as equation number 1. Okay, and next step is partial differentiation. For that, the slope of a displacement curve, slope of the displacement curve for the boundary of medium particle, boundary of medium. Okay, partial differentiation, that is dou yi by dou x plus dou yr divided by dou x, which is equal dou yt divided by dou x. See, just try to understand 1 second. Here I am taking an incident ray that gets reflected and remaining is transmitted. Here AR and AT is the coefficient of reflection and transmission of the boundary of medium, and continuation here two mediums there. That's why here the displacement of medium particle in the two media must be equated. Nothing but here first medium, that is equal to second medium displacement. First medium is yi plus yr, which is equal to yt. Then continuation for the boundary particle x is equal 0. So that's why here x value is 0 here. Then we are getting a plus ar, which is equal to at because of omega t common and cancel. Then slope of the displacement curve for the medium particle for the boundary of medium. That's why partial differentiation of this equation. So then continuation, just a second. See, up to here completed. Now the values are replacing in this equation. See, for this here first initially a minus k1 cos omega t minus k1 into x plus for this value, see, ar common partial differentiation and k1 common and sine become cos omega t plus k1 x, okay, which is equal to then transmitted at minus k2 cos omega t minus k2x. See, for the boundary particle, for boundary particle x is equal to 0. Then the resultant equation is minus ak1 plus ark1 is equal to minus atk2. X is equal to 0. So cos omega t LHS and RHS side common and get cancel. So we got this resultant equation. See, for this we can do k1 is common LHS side. So minus k1 is common, that is a minus ar, which is equal to minus k2 into at. So here minus minus get cancel. So a minus ar, which is equal to k2 by k1 into at. Okay, so this is taken as equation number 2. This is the first equation, this is the second equation. Now equation 1 plus equation 2, equation 1 plus equation 2. So now see here plus ar and minus ar is get cancelled. So a plus a is 2a, which is equal to here at is common, so 1 plus k2, so 1 plus K2 by K1 into EAT. Okay, and taken LCM, so 2 K1 and cross multiplication, 2 K1 divided by K1 plus K2, which is equal to AT by A. See, LCM is K1 plus K2 divided by K. K is multiplied this side K1, so 2 K1 and K1 plus K2 from RHS side to LHS side, AT divided by A. But this value which is equal to AT, small at, that is coefficient of transmitted wave. Okay, so here simply AT, which is equal to 2 K1 divided by K1 plus K2. So first wave in a medium 1 with a velocity v, that is v1 we are taking, that is for the incident wave and also a reflected wave, and medium, in the second medium velocity is taken as v2. So simply first medium is velocity v1 and the second medium velocity is v2. So the values we are going to replace from the basic formula, that is v is equal to omega by k, k is equal to omega by v. So k1 which is equal to omega by v1 and k2 which is equal to omega by v2. Okay, omega value is constant and the values are replacing in this equation, so we will get AT which is equal to 2v2 divided by v1 plus v2. So we got AT value and AR value I will find out just a second. See, we got from this relation equation to A minus AR which is equal to K2 by K1 into AT. So from equation 1 and 2, equation 1 plus 2. From this equation here 2A is equal 1 plus K2 by K1 into AT. Okay, so here rearranging this equation we are getting AT, and in which K1 is the propagation constant of first medium, K2 is the propagation constant of second medium. The basic values are replaced. We got AT which is equal to 2v2 divided by v1 plus v2. Now here we wanted to find the AR value. AT value we got already. So for AR, see, AR which is equal to AT minus A. So AT value is writing from this equation. AT which is equal to 2K1 into A divided by K1 plus K2. So AR which is equal to 2K1 A divided by K1 plus K2 minus A. So AR which is equal to here 2K1 minus K1 minus K2 divided by K1 plus K2 of A. AR divided by A which is equal to, that is K1 minus K2 divided by K1 plus K2. C, K1 minus K2 divided by K1 plus K2. So AR by A. AR by A is equal to how much? That is small AR. Small AR is the coefficient of reflection of a medium boundary particle. See, for this here the values K1, K2 values replacing, then we will get V2 minus V1 divided by V1 plus V2. So this was my class today about the reflection of the wave and transmission of the wave from the wave chapter. Just a second. And please like and subscribe my channel and share to your friends, and also comment about my videos.